All right. Good morning, everybody. We've got a little slide up here showing who we are, so you can see a picture of all of us. I'll get out of that slide there and get back into NX. So here I am in NX 1202. I'm going to go through a 2D and 3D synchronous modeling. Some people may not even be aware that 2D synchronous actually it exists. To start, I'm going to go ahead and do a file open. I'm going to change my part type here to a DXF right there. Wow, it's right in front of me. And as I open this up, it opens up an import wizard. So I can do things on the import where it automatically picks up what the units are of the import. I can heal bodies, simplify the geometry, and optimize. I'm not going to check any of these on because I want to see what it looks like when I bring it in. You say okay and finish that. And then I have a part that shows up. I'm going to change my background here so it's a little bit easier to see, a little bit easier on the eyes maybe. If I look under non-timestamp geometry in my part navigator, I can see that I've got some arcs, some lines, and it's collecting them in kind of a different way. And if you're familiar with DXF import-export, you know that sometimes you end up with multiple lines on top of one another, lines broken up into tiny little segments. So I'm going to run an optimization on this. I'm going to go to curve, optimize 2D curve, and it wants me to select curves and points. So I'm going to select all these curves, and this is going to optimize. So everything that's doubled up on top of each other is going to create a sketch. So I'm going to specify a thesis and just let this be an absolute thesis on this particular part. I know I brought it in the absolute. I could pick other geometry if I needed to. This is actually going to turn it into a sketch for me. So now I've started with the sketch. So get in here and I'm going to edit the sketch. Just double click on it and I'm going to get into the sketch itself. And I can see here that I need 182 constraints. So pretty much there goes the rest of my morning trying to get this one constrained if I really wanted to do that. And you can see it here that I could just pull stuff apart. So while I'm in a sketch, this little gallery right here has a bunch of tools in it that unfortunately are hidden in this little drop down. So what I've done is I pulled them out and put them over here, and I made my own little grouping. I'm going to use a move curve. And I need to make an edit to this. So basically my workflow on this is it's Friday at 4:45, and the boss says we need to make changes because the laser table needs to get an updated part. And the only thing we have is a DXF, and that guy's on vacation. Go. So I want to make some changes here. Pick a move curve, and with synchronous tools we get this finder, and this one is a curve finder. So we can see symmetry left, right, and top, bottom. So I can see how it's picking the curve geometry up. And the next piece of geometry that I pick also brings up my curve finder again. So it sees, again, symmetry left, right, and top, bottom. So if I also pick up, say, concentric, it's picking up one of them, but only picked up one. So I'm going to leave that behind right now and then try to pick up that circle. Then again, I can see symmetry left, right, and top, bottom. But for some reason, it's kind of missing this one down here in my lower right-hand corner. I'm going to uncheck that one and then pick this guy and then see if I can pick up symmetry that way. So there I've picked up symmetry across the part. This is, again, unconstrained. I'm going to flip my axis, and I need to, the job was to move this out, say 75 millimeters, make it wider by 75. So I'm going to make it 75 divided by 2. You can see here I get a preview of what's going to happen. So 2D synchronous is allowing me to essentially keep my sketch essentially constrained, but it's not constrained by normal approaches of what we see in NX. Again, if I wanted to do an offset move curve, I can have it pick all connected curves up here, and I could scale this part by say 2 millimeters, and it will offset that. Let's make it a little bit bigger so we can see what's going on. 10 millimeters, and flip that to the other side, and you see how the overall part's just going to grow in size. And I'm just going to cancel that. I'm going to do a resize curve. And if I pick my fillet over here, I can see symmetry again, left, right, and top, bottom. And I can change it as a fillet, so I can make it softer or sharper. Or I can change it from center, and I can see how it's going to scale my part a little bit. Okay, but it maintains relationships that it sees as logical relationships in my part. So that's a legacy 2D to basically a 3D workflow. From here, it'd be very simple to turn this into a 3D part. Okay, so I have a sketch again in NX. I can turn this into a 3D part. So I'm going to open up another part that looks almost exactly the same. But this one, when I go into the sketch, this is fully constrained. I see right here it's fully constrained. The nice thing about this tool set is the same problem arises. I need to make this part 75 millimeters wider. I've got a dimension right here. I'm just going to double click on that dimension and edit it. I'm going to go to the end of the dimension and just add in. So plus 75 divided by 2, and it's not playing nice. I see some things that are not operating properly. Go ahead and close that. I'll Control Z and bring that back. Maybe I can try it a different way. Maybe I just say plus 50, see if I can get it to bump out, and then I get conflicting constraints. And it's just telling me that there's an over constraint condition. And one of the things that I find in my line of work is the worst possible sketch out there is somebody else's sketch, because you really don't have any idea how they put it together. And the second worst is my own sketch 2 weeks later, because I don't remember how I put it together. So I'm going to use move curve on this. And for this one, I'm just going to grab all of this geometry down here. And I can see that it picks symmetry left, right. I'll flip my direction arrow, and I'll key in 75 divided by 2. And if you pay attention to these values up here, you'll see things change. So it went through and recalculated my distance, my dimensional constraints that I have on the part, and it's still fully constrained. Okay, so that in itself is pretty awesome. Another workflow that I have is I need to rotate the center section by 45 degrees. So do a move curve, select all of these, and I get a little manipulator that shows up down here. I'm just going to drag that so it's stuck in the center so I can rotate that 45 degrees. And I want you to pay attention to P24 at 15 millimeters right here. Also, we've got some horizontal constraints and some vertical constraints. Okay, so I key this in at 45 degrees. It rotates. I get a preview of it, and I say OK. And then now I need 9 constraints. It took that 15 millimeter dimension and turned it into this 10.6. And if I throw another dimension on here, it's at 15. So it's maintaining the relationship, but it's also, this is a horizontal dimension, so it's the same length of line, but at a horizontal dimension. I probably wouldn't want to leave it like this. I'd want to go through and constrain it, but again, I really only have 8 constraints to finish on this. So with that, it's really a time saver to a great degree. There's a delete curve in this set. So if I use a delete curve and just start working my way around, you'll see how it's going to heal. And I have heal checked on over here. So yeah, you might ask yourself, why do you want to have a delete curve when I can just select the curve and then delete it and it goes away? Well, the reason for that is because it has heal built into it. So if I select my same curve, you can see how it's going to preview and show me the end result there. So what I want to do is knock off these ears. And I'll use a delete curve and then pick these curves here and these curves here. Okay, and now I need 14 constraints. So it's removed geometry. This is now a single line all the way around, and I don't have to worry about things moving around on me unexpectedly. So I can use delete curve to make that work. Same thing exists on this one as well, as far as if I were to get rid of these curves, maybe even this one here, and I wanted to make these two coincident, things are going to move around unexpectedly. But if I back this out, Control Z, make my delete curves, it will heal, and then now I just have a single entity that's left behind. One of the things we all do is we have to deal with neutral CAD geometry. So I'm going to go ahead and open up a step file. And if you notice here, there is a .stp and a .step. So I downloaded a screw from McMaster-Carr. I'm going to bring it in. Let this open up. And I see my part. And it's got threads on it, and I see half cylindrical faces here. So in NX, when it resolves other CAD geometry, it turns turns it into half cylindrical faces on both sides. So on my home tab here, I'm going to come over to my synchronous modeling toolbar. I'm going to come down to optimize face. Optimize face, when I select all body faces here, it's going to tell me that it's going to remove parameters from the part if I have parameters in the part. This one doesn't have any in it, so it's probably not going to ask me anything. But what it's going to do is then remove those half cylindrical faces, and then the number of entities that it has resolved has gone from 327 down to 214. If you look at CAD as a tool, the hidden line rendering is something that takes a lot of processing power. So all these threads that are on the backside are causing a lot of processing power. So if I have a lot of these screws in my assembly, then it's going to just hit my video card and slow things down and make my performance a little bit slower. So I'm going to clean this up a little bit more. I'm going to use a delete face and just delete that top chamfer off there. I really don't find that to be all that useful. And then sometimes on these, I know things are going to fail, so I'm going to go ahead and pick the root, and it goes to a sharp. As soon as I pick one of these threaded faces, things start to fail, and I know that's going to fail. I'm not done picking everything yet, so I'm just going to go ahead and uncheck my preview and go through and pick some of the ones that I know that I need to pick up in this part. Then at the end, I can say show result, and there you go. Just say, okay, now I have a smooth shaft. I want to make this part a little bit smarter. I see that I have a chamfer on the end here, and I want to put what's called a linear dimension. So I'm going to create a relation to my part. Okay, this part is 50 millimeters long, and if I were to key in that I want it to be 60 millimeters long, I see a mistake. I missed something here. It's missing that chamfer on the end. So I'll come back to my faces to move, and I'll pick up that chamfer, and now I can move that 60, 75, show result, and I'll key it back to 50 where I'm starting and say, okay, what can I do with this information now? Well, I can go to my Tools tab right there and turn this into a part family. So very, very easily, I have to find out what my p-value is. It's p10. I could rename that to something more logical, but I'll go in and make a part family, take p10, add it to the list below. Then from here, I can create a part family out of a relatively dumb part. So I could key in that I wanted to be at 55, 60, 65, and then, part number 1, 2, 3, 4, 5, 6. I'll copy all of these over. And then if I select one of these lines, I'll go down to my add-ins and I'll verify the part. I'll apply the values or verify the part. And I can see that it's updating properly. Resume spreadsheet. Try one of my longer ones. Maybe I'll make this one 100 millimeters long. And verify that part. I see that it's applied properly. And I can build a spreadsheet up from this. So from here I can just say family, escape out of the spreadsheet. And my family has been created. And I can then use this for assembly work. I've got a part here that through either translation errors or just over time it's drifted for whatever reason, and people hadn't caught the things that are wrong with it. If I look into this bore, this looks like it's supposed to be concentric, and it's not. I got another one over here that has a concentricity problem. And then I look at this face over here, and if I section my part, let's change where that rotation vector is, I can see that I've got like an inclined wall here. So again, on home, I'm going to come over here to say make concentric. So I'm going to make a relationship here, or rather make coaxial. And I want to pick the motion face. When I do that, it sees that there's other coplanar axes. I'm not going to pick any of those right now. I'm going to pick the stationary face, and you'll see how that hole moves and becomes coaxial. Same thing over here. I'm going to make coaxial. I want to pick again the motion face first, and then the reference stationary face. And then that will rotate around, and it is basically a spot face that comes off the edge of the part. This one might be a little bit tougher. We'll see what we can do with it. I want to make this perpendicular at the very least. So I'm going to tell it to make perpendicular, and I'll pick the motion face, and then pick the stationary face. And when I do that, I see how it's adding in material and it's pushed the bottom out. But what if the bottom is where it needs to be? I can specify a point to go through, and I say I want the bottom to stay the same, and now it's going to be made perpendicular through that point, and it's pushing the top back instead of the bottom. Just say okay there, and I'm off to the races. I've got the same part, but this one is fully featured. I look at my history tree. There are nearly 460 features in here. So should I use synchronous modeling on something like this? Well, it depends on what you're doing. One of the things I need to do is I need to make this pocket bigger. So I look at that. It's a feature, extrude, and it's got a sketch inside of it. It's got a value of 50. Let's make that maybe 85. Finish that and see what happens. Let it go through an update. Crunching through my updates here. And all right, well, now I have another feature that it's interfering with. I can select that feature, see it over here on my tree, and I go in to edit this one. If you're familiar with NX, well, basically in the old days, this one actually predates me a bit. I've been doing this for about 16 years, and this is a dialog that predates me. There is a way to get in here and edit the defining string and edit the sketch, basically that's driving this feature, but it's kind of an old feature. And maybe that guy retired, and we don't have the knowledge of how to fix this part anymore. And just real quick, we can take a look at how old this part is. So menu information part history, and it's picking up the part that I'm in. I roll this back to figure the first couple ones are just building a template file, but back in 2000 is when this was really created. And it's gone through many iterations through time, and is now opened by me today. And the version is 432 at this point. So it's gone through a lot of changes over time. So I'm going to fix this guy, maybe push this value back to 50. Let that all update. So the question always comes up, am I overriding the design intent of the part? Well, to a degree, yes, I am, but I don't know how to fix that feature. So I'm going to go ahead and use move face. Pick this one face. And I can reverse that over and say I want to move that up 35, so it's the 85 overall. So that was just a move face with a specific value added into it, and now I have a move face feature that shows up on my tree. When you see these, you are overwriting the original design intent, but what I did was just move the face. The face ID is staying the same, and now I'm no longer interfering with a previous part or previous feature. One of the things that NX's claim to fame is that it can open up parts that are really old. This really just started in McDonnell Douglas back in the late 70s, early 80s, and though I've never seen a part from the 80s, my oldest part I've ever seen is in the mid 90s, and I was able to open that up no problem, and we were able to work on it. So I'm going to open up another part here where I need to do some synchronous modeling on. One of the things I want to do is I want to bump this face up by, say, 2 millimeters, 3 millimeters. Use move face. And move face, I pick the face that I'm interested in. And it does find some offsets in here, but I'm not interested in the offsets for those because it could be picking faces on the far side. I just want to move this face. And as I start to drag this up a little bit, you'll see that my chamfer is not staying as a chamfer. It's just blowing out the rest of my hole. So I'm going to cancel this. Now my synchronous toolbar, there is a label chamfer right in detail features. So I'm going to pick this chamfer, apply that. This chamfer, say okay there, and now on my tree I've got a part body, which is just a parasol that is where I open this from, and it's got a couple label chamfers in here now. Now I can do a move face and key in that I want to move this up 2 millimeters, and it honors that and moves it up. So Make that 0 for right now. I want to pick up some more stuff. I want to pick up the bottom pocket here. And when I do it, I want to grab all of those bottom pockets. Then I have to pick up coplanar, and then it picks up all those coplanar pockets, but I can see that I'm going to try and move things that I don't want to move. So I'm going to hold down Shift and unpick that one. So it gets exactly what I want. And I'm going to move that up 2 millimeters. And I can see that it's honored and it's moving up 2 millimeters. Not sure how to get rid of it. Oh, there we go. I want to knock off these little tabs right here too. So I'm going to use a delete face. And I'll pick a single face, and then I can just right click and I'll say I want to change it to boss pocket faces and see if that's going to pick that up as a logical feature. And I can move over to this one and see if it picks that one up as well. I can show result, see what happens. Yep, did what I wanted it to do, and it's gone. One of the things I want to do too is I want to increase the bore size here, and in order to do so, I'm going to bump out the size of my flange. So I'm going to use a move face. I haven't really shown this one off yet, but this little purple handle set in here, this is called the Orient Express. And I really want to change this to go in the direction that I want it to go in. I'll key in that I want this to be 3 millimeters. So I can see here that I'm just adding material, but what I really want is I want all these pockets to stay at the same thickness, or the wall thickness is staying the same. So I'm going to pick offset, and you see how it picks up a few of those pockets, but not all of them. And I try to pick up tangent here, and it sees those as tangent pockets as well, and now it pushes that face out that value. Do the same thing over here, do a move face. Again, Orient Express, pick the vector that I want to work in, and give it 3 millimeters, and you're going to see that it's got some problems. It doesn't like this edge blend on here. So again, this is an unparameterized part. I don't really have any way of editing this edge blend except for maybe getting rid of it and putting it back on. So I'll use a delete face, and under delete face, I can use a blend and then try and pick connected blend faces and see if I can let that delete out. And it doesn't like what it sees. Doesn't like this patching down here. See if I can try a different one. Maybe come up from the underside. Delete a blend, connected blend faces. Try to apply that. Doesn't like that either. If I bring up my preview, it shows me some issues with this area right here. So I'm going to use a different technique to get rid of these. So one of the things I can probably do is maybe just use a blend, and I'll just pick a single face on my blend, and then preview that. I can get rid of some of it. It seems to be okay with that. I could work my way around this part and get to the other side if I needed to. And okay that. But this is still being a problem. So I'm going to add some geometry in here. I want to go to a standard modeling tool. I'm going to add a sphere. Put a 4 millimeter sphere. I have my Boolean set to unite, and I'm going to pick a point on a face to drop one in right here. And apply that. You can see it's kind of taking over that geometry right there, and I'll make another one right over here, right next to it, and okay that. Now I've got two spheres that are put in place. Come back here, do a delete face. I want to delete a blend, and do connected blend faces. Grab both of these. Seems to not like what I've done over here. So maybe I can do a delete partial blend in this zone. Gets rid of those. And then I'm going to clean out these spheres. Do a delete face. Apply that. See what's going on over here. Maybe delete that face too. Oops, that's set to partial blend. And uncheck that one. Now I've cleaned up that geometry. And I'll do the same thing. I'll do a move face. Grab that face. Orient Express. Give it my 3 millimeters. And it's probably not liking something that I left behind over here. So again, I'll do another sphere right there and make it 4 millimeters. That's a bit big. Oops. And then delete this face as a single face out. It doesn't like that so far. The nice thing about this too is I can always back this out. I can get rid of the features that are causing this to fail. And that delete face is back in there. And I'll throw a couple more spheres in here. And maybe one over here, just for good measure. And delete face, blend. Delete face, get rid of that sphere, maybe this sphere too. It's probably too much to ask for that one on that side. All right, more cleanup work to do. Like it when it works in practice, and then I have to adjust. Delete a blend here. Apply that. Didn't really delete out what I wanted there, so let's see if I can delete this face. Yeah, I'll have to come back and fix that in a minute. Take a little bit more work in that corner. I'll move on. I've got another feature over here. I want to raise this feature up, so I'm going to section this. I want to turn my section curves back on so I can see what's going on. I'm going to just use a move face. I'll pick this top face and move it up 2 millimeters, but I also want to pick up the offset. So it grabs that bottom face as well. I can show result, see how it's going to move up the 2 millimeters. I say okay. I also want to do a move face on this this little angled area right here. And I'll give it a vector and move that up again 2 millimeters, and it doesn't like it. There's a blend around here. If I go to my view tab and unclip my work section, I can see it's probably interfering with this blend. So I'll unsection my part, do a delete face, connected blend faces here, and it doesn't like going all the way around this part. So what I'll do is, quite a few that is picked up there. I'll hold down Shift and then use my radio pop-up to then grab just that one face. And I can walk my way around this and pick up all the ones I don't want to be deleted. Oh, and there it goes. So my blend is deleted. I might want to just keep this geometry the same over here without editing it and get rid of that deletion right there. And say okay. Now my blend that may be causing the problem is deleted. I'll bring this back and toggle on my section. And I'm going to try to use a move face again. Pick this face, pick the other face that's under it, give it a vector, and 2 millimeters. Still doesn't like it. So I'm going to try another one. I'm going to use move face, or rather pull face. Pull face is much simpler. There's not as many inputs in it. And there it goes. Got that to pull up, no big deal. And I want to clean this up. Go ahead and turn off my section. I'll just use a delete face, single face selected, and there you go. Now I can go through and reapply blends, maybe go back and fix this little problem that I have over here and offset my face again. So where are you going to use this information at? If I come over here to my folder, I'm going to open up a vise. Go ahead and open up this guy. This is a Kurt vise. This particular one, I believe I've got this correct. That when I crank this down, both jaws come in at the same time. But when you look at this, it's all one body. So I need to start breaking things up. One thing I like to do is I like to get rid of all the screw heads, because if you look at this in a wireframe mode, you'll see that there are just tons of little features on the inside. It's going to cause me nothing but heartache, so I'm going to go ahead and get rid of them. Again, I'm going to use delete face, and when I'm in a wireframe mode like this, I'm able to pick all the way through the part, and I'll grab all of these and all of these, and show result. They're gone. Say OK, and then I'll section my part so I can see through it and look down on the end. I've attempted this on the sides, and it's trying to pick up too much information, so I'll try it just from the end face. And again, I'll use my selection here, grab all of that, and say OK, and it all goes away. I'll unsection my part and take a look at it. All of those little threaded features are all gone. Go back to a shaded view, and I'm off to the races. I need to break these two off of the body. So since it's just a single body, I need to start breaking up some faces. So on regular modeling toolbar, I want to use a divide face. I want to use not just an object, I'm going to actually create a line by 2 points, because I see a little step right here. I'll pick that point right there to this endpoint down here, and then I'll select the face to divide. This is that guy right there, and apply that. Now that face is broken off. I have to do the same thing on the other side. I'll select the same face, rather the opposite face. Move it down to this side. Oops, missed it. There we go. Now those faces are broken off. I'm going to use a tool called Group Face. Now on Group Face, again, I'm going to switch to wireframe mode on this and flatten my view out. I want to grab everything in this moving clamp head. And just say OK there. Now I have a group face group, if you like. Again, I'm going to use a group face. Grab all of these on this side. And say OK. Now I go back into shaded mode, and I've got two group faces. So let's see if it works. I want to throw on a linear dimension. I know I want to drive this with a dimension. So I pick this edge, and then this edge. Bring it out, and I can see that it's 3 and change, 3 1/16. I want to put it in at 2 inches. So I can see that it's not grabbing the entire thing, it's just moving that one face. So on my faces to move, when I pull my face roll intention down and pick feature faces. If I pick that as a feature now, it sees it as feature faces. I don't have to go through and repick it all. So now you can see the preview is already showing me what I want. Okay. So my linear dimension, I see that the expression is set to P4. I'm going to do the same thing on this side. So I make a linear dimension from here to this face. And since I already know what it's going to do, I also want to pick up all the faces to move as feature faces again and grab this one. And the value I want to drive in here is P4. So now if I look at P4 and put in that I want 0.5 separation, now it's separated by 0.5. This is not an assembly. I'm just using move faces to drive my part around. And the default value on this was 3.062, so I'll push that out to its default value as it was original, and I can see how my part moves back and forth pretty much as expected. If you wanted to go further and change out these faces to soft jaws and the like, there's other tools in here as far as replace face and replace it with this one, and then start deleting this face out, and then maybe cut new holes in it for attaching different types of jaw material onto this part. So there's taking something that I see a lot of cam guys are always looking at to be able to modify the parts that are coming into their world. I'm going to switch back to another part here. Again, this is a fully parameterized part, but you may have to add on geometry to it. So how do you modify existing geometry on the part? Well, on the curve tab, what I want to do is I want to break out a little section here. I want to create a little tab that comes off of this so I can throw a clamp on it, maybe one on the other side. And I've got a tool here called line. So I'll just pick this as a line, and I want a point on a curve snap point to be turned on, so I can pick it anywhere along this edge here. And as I pull this up, I can see that it's pulling up in Z. I'll get close to the top. I don't really need to get all the way to the top. I say okay, or apply that. I want to do it again. Again, I'll let that float up in Z. And then I'm just going to pick those two endpoints. Now I want to break this out and pull it out of my part. Again, home. I'm going to use pull face. And on pull face, there is a thing called region boundary faces. So it's going to pick that as a region boundary and let me pull this out. Now, my line probably wasn't very straight on the top. So I'm going to make another relationship. Say make parallel. I want the motion face here. And my stationary face could be the bottom. Could be the top one too. It's also flat. And say, okay, now it's parallel. And I don't know what size this is. So I could go in and throw in a linear dimension. Oops, let's do that better. Do a linear dimension top to bottom. Maybe I want that to be like 3/4 of an inch. So I put in 3/4, and this is in millimeters. So I'll just put in inch and see if that takes it. It doesn't like that. So 0.75 inch. There we go. And the way I put this in is as I'm trying to move the entire bottom face. So I'll reverse this one. I'll do another linear dimension. This is my origin. 0.75 divided by 0.75 inches. And there we go. So very quickly I'm able to create geometry and pull that out. So I'm going to do it again on this face over here. So I'm going to go to my curve tab, line, pick a point on that edge and let that just kind of go up in Z, so I know it's a pretty straight line going up. May as well use it if I got it. Apply that and let it snap to the midpoint there, and maybe even the midpoint over here. And again, I'm going to use a pull face with region boundary right there. Pull it out to a value, and again I can straighten things out and put a dimension on there if I like. So we're going to get another part open here. And this is a kind of a late change approach. So the part was created with, if I roll this back just a little bit, so make this the current feature, it was created with a flat top. And there was a late design change to put in this dome. And if I look at my part, I'd already done all the work to shell this out. I don't want to have to spend a whole bunch of time rebuilding my part from scratch. So what I want to do is create another relationship. So I'm going to do a make offset. So let's see this in section view here, because it's a little bit easier to see what's going on. Again, I can turn my section lines back on so we can see those as well. I'm going to do a make offset, and it wants the motion face first, and then it wants the stationary face. What it does is it measures that thickest value that's in there. So this could also be good for trying to interrogate a part, but I want this to be 6 millimeters. And say okay, and then now that's 6 millimeters thick. If I look at my part navigator, I see a make offset in here, and then it's matching the similar wall thickness all the way through. Unsection that, and I can turn my section curves back off. One thing I see a lot out in the world is you want the ability to be able to know what the internal volume of a part is. So I'm going to go ahead and delete this one little tag out of here, and I'll roll back this a little bit and also get rid of my extracted body. So I have my part shown here. Actually, I thought I saved it like that, but that's all right. I'll just back it up a little bit. I want to use something that's not necessarily intuitive. I want to use a delete face, and I'm going to pick all tangent faces, and I'm going to delete out that inside surface. Well, you just see right there that it's just going to fill that up. There's a tool called all but selected. It's not invert selection like you would normally expect, but it's called all but selected. And when I pick that, you can see how it it flipped it over and it got rid of the outside. I can say okay, and now I have the internal volume. But then again, I just um, uh, consumed the body that I actually want made. So I'm going to get rid of my delete face. And right here on Edge Blend 8, I'm going to right click on that and say extract body here. Okay. I'll select that body, do a Control J, maybe turn it into a different color so I can see the differences in it, and make it blue. Then I'll hide the original body and do that all over again. So I'll do a delete face. Tangent faces are selected. I'll do an all but selected, where when I select that, you see how it flips it over. And then okay that. I'll show that one. Now I can see the internal volume as well as the external volume. If I go back to the original extrude and change this out to maybe 105, my part gets bigger. As you would expect, the internal volume gets bigger. And I want to measure that. So do a measurement. I'll pick the object, but I'm going to press and hold my mouse button 1, and I want to grab the solid body of that extraction. And I can see here all the different things that come up with this new measurement tool that we have. And I can see the mass, the weight, everything is going to be steel until I told it otherwise. I probably should have told it that this is water. But I'm going to turn on the center of gravity and have it create the principal axes, and as well as create the geometry for that. And then I also want to turn on a couple of, say I want to turn on the volume. That's a tag now, and just say okay. And now I have a tag that says what that is, how big it is. If I go back to my measure, if I right click and refresh, I still have a volume tag that's on here, and the center point of gravity. I'll switch this to wireframe mode, and I can see my CG of that internal body right here. If I did go into menu tools, materials, assign materials, I say I just want to see what it is in water. Pick that body, apply that. My face, my measurement, should have been paying attention there. Oh, I need to look at my measurement and see what happened to my mass. I should have turned the mass on, but failed. The mass has dropped down to what the mass of water is. And one that I like to show off just because, well, mainly it's fun, but you can also use it for other things. There's a tool called Move Edge and Offset Edge. So what Move Edge does for me is it just takes an edge and allows you to move it. Now, this is doing some pretty crazy things to the topology here. And where I tend to use this mostly is if you have a complex surface with embossed, say, text on it. It's got your company logo on it, and then you need to put draft angles on it, and nothing else is working. Draft is not doing what you want it to do. You tried everything in the book. Go to Synchronous, Move Edge, or Offset Edge, and I'll show that one right here with this little polygon. Do an offset edge, and I'll just pick all these top edges here and just drag this in, kind of turn it into more of a cone shape. Then I'm going to do a move edge on it. Again, I'm going to pick all those top edges up here, and I want to pick a vector, and then pick the point that I want to rotate that about, and I want to pick a point on a face. And I'll switch this to just angle. Oh, I lost my vector. Have to rebuild it. So do a point on my face here. Again, 0.5 is halfway through UNV, so it's going to dump it right in the center of the face. And now I'm going to take this little handle and drag it around. So I've twisted my bar quite radically. If nothing else, it's fun to play with, and it gives you a good understanding of what NX is going to try and throw at you. So I just do distance on this one, pull that down. You can see how the topology is going to morph into it. Okay. One of the other things I do as I get close to the end of the hour here is I'm going to open up a part, and I've not seen this part before. it comes into my, let's say, my drafting queue. And I can see that it's just a dumb body, but there's nothing on my screen. So go ahead and fit, or in NX12, I can double click in the background and it'll fit my screen. As I zoom in here, I see my half cylindrical faces again. And I want to resize these faces. So I do a resize face, pick this one, and it's not letting me pick anything. So again, there's no parameters in here for me to blow up anyway. So I'm going to come down to optimize face. I want to pick body faces and pick this entire body. 269 faces are picked. It says it's going to remove parameters. Do you want to do that? Sure. There's nothing, I'm not going to lose anything on this part. And when it's done, it tells you what it did. So there was a total of 801 entities originally, and now it's down to 397, so a little bit less than half. If I zoom back in on that same hole, it's now looks like a hole. So I'll do a resize face on that hole, and I can see that there are 21 of them throughout the part. This is where I kind of use this for my drafting workflow. If the engineer put holes in with 15 different features and it's hard to do a count up of those, I'll just use synchronous modeling, if nothing else, to count them up for me. Again, I'll do another resize face, and I'll pick this other hole here, and I see that I have 78 of them. Okay, but what I really need to do on this is do some move face commands, and I need to move this whole set, reverse that, and move it down a little bit. Maybe it's 8 inches. I need to move it down, and okay that. I'll do another move face with this grouping, and give it my Orient Express again, and change the vector here, and I want to drag it right through some other features. You see right there, it doesn't really seem to have any problem going through those other features. If I stop here, it's going to consume that hole, but I still have a feature over here. If I double click on this feature and drag it a little bit further, that hole is still there. However, if I did a second move face on top of that, maybe not move this one, I'll shift pick that again with my Orient Express and pull that out. Since I consumed the hole in the last feature, that hole is now gone. So I'll Control Z that, and then just go back and edit this one so that it goes where I want it to go. Okay. The last little bit on this one is I like to break this little tab off the end. I'm going to use a divide face. And the face I want to divide is a single face down here. And I want to just do it by an object. And I want to pick this other edge that's right there. And you see how it projects into this face? Now it's broken off. Now this is called a smooth edge in NX. And I may have to do some adjustments when I do my move face. I'll pick this far face. And then this one right here. I don't want to use offset or coplanar because it's going to pick everything down here on this end. And if I go to drag this off, it has a problem. If I check on this, it says you got a tangent neighbor that doesn't know what to do. But I have a setting down here called step face. Go ahead and say I want that to extend at step face, and I go ahead and it'll go ahead and pull that off the end. So about 10 minutes to the top of the hour. And I'd like to, I want to check to see if we have questions in here. Is anybody going to type any questions into the field? I'll be more than happy to answer them right now. If not, I'll kind of continue on for the next few minutes and show off a few more tools here. So I've got a part that's got a bunch of holes in it, but I don't know how many. I could manually count them, look at the drawing. Maybe the drafter put how many X there are, but I've got holes all over the part, and I just want to use my synchronous modeling tools to interrogate things. So again, I'm going to pick my resize face. If I pick this guy here, it tells me what size it is. It says it's a 5 millimeters, and I have 18 on that face. If I pick far, then it counts up a total of 30 on far faces. So it walks its way around the part to find the far faces. So equal radius far, we'll pick those up. So I don't really actually need to do anything. I just wanted to find out how many there were. Okay, I've got another set over here. So again, I can use resize face. It says equal radius 4. There's only 4 of them on the part. And these are counter bores, and I can't do both of them at the same time, but I can just do a resize face and pick up that I've got a 9mm diameter that I have 12 of them. If I pick up this one as well, then I'll see that I have got 24 faces, but it's not changing my value here, so I don't really know what size that counter bore is. So I just go through and do another resize face at the counter bore and see that that's diameter 15 right now, and there's 12 of them again. So I can use my synchronous modeling tools to help interrogate my part as well. Oh, the difference between move face and pull face. That's a good segue. I have a move face where if I grab this face down here and start pulling it out, it's going to honor the fact that this face has rotation in it, or has pretty much an edge blend on it. So it's going to go out until it fails. It's going to try and work its way back on itself. If I cancel that, I'm going to move this to pull face, and pull face is just going to pull that face straight out. Okay. Another example is this guy right up here. If I use a move face and pull this up, see how it's going to just fill this gap in until it runs out of material to work with. Again, I'll cancel this one and use a pull face. It's going to grab this face and move it straight up. Really powerful tools, and when should they not be used? I don't like the idea of overriding a design intent necessarily. But it does build a feature tree over here. Like this block here was created with a sketch and extrude. So if I look at my original sketch here, it's got values that are driving it. So if I needed this to be, say, 12mm wide, whoa, I just want to edit the feature. Make that 12 wide. I'm not overriding the design intent of what I originally intended. I'm obviously missing something here on my extrude. I would probably have to make sure that my other extrude is working, and I have a fully featured part. Where this really comes into play is when you don't have any features on the part. Obviously, synchronous is the best way to go. But if you end up with that one thing that you just cannot do, so one of the things I want to do is I want to replace this face with another surface. So I'm going to do an extrude, create a new plane on the fly. I'll just make a bisector plane here. Set the through object, that's what messed me up. So I'll set it as a bisector plane. I'll cut the part down right at the center, give it a horizontal vector this way. Oh, sure, it's upside down, that's fine. And I'll throw a studio spline in here, so I have that little swoopy surface. And I can do a tool called replace face. So I'm going to use a replace face, grab all these faces down here, maybe not this one. Then I'll use this as a replace face option. Doesn't like what I did there, so I'll go ahead and pick this face as well. But I could also put in an offset. So I want that to be 1mm or 1 inch offset from my replace face. So I've kind of combined two things into one. So if you did have an extrude to a surface minus a little bit, this is the best tool for it because it already has it built into it. And I don't have to then, I could have done a replace face or try to pull all these faces up till it intersects my sheet body here. If I copy this down real quick, so it's kind of intersecting my part, I could use trim body, trim that off, and then I'll have to do an offset surface, offset face to get the offset that I wanted off of that trim body. So in one operation, I can take and do a replace face. Again, I can grab all of these top faces up here, select this face, and then give it an offset of 0.5, flip that to the other side. And it's just a synchronous modeling tool, but I'm using it for a normal approach. Question is, are they available only in NX12? This one goes back quite a ways. If you are running even all the way back to NX7.5, you're going to see some synchronous modeling tools that are in there. They've improved them since then. Some of the tools they've added a few sets of tools in here as far as this edge offset and move. There's a replace blend that's been added in over the last several releases, but pretty much this is an unchanged tool set over the last 2 or 3 releases for sure. Where did my questions go? Okay, I think I may have answered them all. Let's see. And then got 4 minutes left to the top of the hour. I want to do something real quick. I'm going to open up a plastic part here. And I could look at it real quick, and I see that it's not necessarily symmetric across my part. So I'm going to do a make symmetric, and I want to pick the motion face, this guy here, my plane that I want to make it symmetric about, which is the plane at the bottom. And then I'll pick a stationary face on the other side, and you see how it's going to make that symmetric. So I'm going to use something in my reuse library. I've got a thing called map parts, and I've got a face grab. I'm going to look straight down on this. I'm going to right click on my node here. I'm going to say find reusable object. Now I'm going to pick a set of faces. There's a bunch of things you can pick here. Thinking about doing a webinar specifically on this. Give it an orientation. I kind of want to be able to drag it around at the base of my part here, and I can give it a face. Maybe this is a screw boss. And I'm going to give it a preview. Just like this, I can adjust the size of it, make it look a little bit nicer, and that's good enough. Say okay. And now it's taken those faces and copied it into this part. What am I going to use that for? Go ahead and get rid of a few operations that I've done here. And if I look at my reuse library, I'm going to take this go to the right location. I'm going to take the screw boss and just drag it into this part. And I'm going to tell it to add. And it just does. So if I section my part, I'll section it right through the center here. See that it just added that in. And if I don't want the depth of my pocket here to be too far down in there, I'll just grab a move face. Missed that. Ended up picking the face on the far side. There we go. Now I can just pull that up to a depth that I want. And I've added in a screw boss directly where I want it to be. And I just drag and drop that and put it where I want it. So with that, it's 11:59. If there's any other questions that come in through chat or through the question tool that's in the meeting, I will write up a detailed answer and share it with the people, the attendees of this webinar. And I thank you for your attendance and look forward to seeing you again in the future. Well, at least being part of my webinar in the future. That concludes my synchronous modeling webinar. And again, if you have any questions, I can be reached at mmartin@appliedcax.com. Shoot me a question, and I'll do the best I can to answer what you got. Have a great day.